Hello everyone, today we are going to talk about how we can implement this hash table in Python. Again, we are using a list in order to store the elements of the hash table, and each element, as we are using the separate chaining technique, will be a list containing the pairs. These are the buckets that we have mentioned in previous videos. Let's take a look at the code. We have here the new class, the class that is called separate chaining hash table, that includes a list of lists that will be the buckets. We can get the number of elements, and more important, we can compute the hash function for a given key using the hash from Python module the number of positions of this table or the list. Let's take a look now at the methods to get items and to set or update items. Here they share the first lines, because we are here computing the hash function for a given key, obtaining the index, and then retrieving the bucket from the table using this index. After that, we have here the for loops that will iterate over the elements in the bucket. If they find the key, in this case, this returns the value, and this updates the value for this particular key. In the case of not finding the key, for the get item, we are throwing an exception, and for the set item, we are including a new entry in the table, updating the size. Let's take a look at the cost of this class, or the methods in this class. First, focusing on the hash function. This is an operation that has a cost that is constant with the size of regarding the size of the table. So we can consider that this is an operation that has no cost. In the case of the get item and the set item, the cost is dominated by the for loops that are linear with the size of the bucket, and that's the reason why it's important to keep the length of the buckets under control. With a fixed size, the buckets could contain a lot of elements. After finding the bucket, we should look for the key using these for loops that we have seen in the code. This involves a linear cost with respect to the length of the bucket. In the worst case, that is unlikely, this is linear with the number of elements in the table. This means that all the elements are in the same bucket. A more realistic case, the average case, involves a cost that represents the cost of computing the hash function plus the load factor, that again represents the average length of the bucket. In order to keep the performance of this implementation of the hash table, we have to keep this in mind in order to control the growing of this load factor. We will see how we can address this in the next video. Thanks for watching, and see you in the next video.